Okay, let's find forces applied to the bench by the bases in both diagrams. Now let's look at this one, which is easier. If I take this one as pivot, of course the torque is applied with the red force, which is the force of gravity applied by the center of the earth. Imagine center of the earth, there's lava, it's burning, it's red. So anyways, this force of gravity is bringing this blue part of the bench, giving it a rotation, the torque to bring it down. So we need a torque applied by this purple base to take this up. And since this distance is 1, this distance is twice, the distance of this force with the pivot is twice of this distance. This must be half of the 5. So this must be actually the F1 must be half. Let's call it F1, which is half. Half of the 5, which is 2.5 newtons. So this is half of this one, because the distance is twice of this one. And we learned in the previous video. In here also you can see how mathematically it's been described. Stop the video and look at this mathematical solution to see the reason. Now we are looking for the force applied in here. Also there is a force applied in here upward, but this force is not causing any torque for me because the pivot is on the force. So the R, the distance of the force to the pivot is 0, so there's no torque here. So I'm going to just forget about this pivot in here and now forget about torque in total. I'm just going to forget about the torque and just look at the forces now. I focus on the forces now. And I consider the total force 0 because there is a balance, not only in rotation, not only in the torque, but also in the forces. So there is no movement or there is no acceleration. So the total force is 0. Therefore, obviously, the addition of the upward forces must equal to the addition of downward force. I have 5 here, I have 2.5 here. I definitely need to have another 2.5 here, right? So these 2 will cancel this one. So there is no movement in this bench. Now let's look at the other side. In the other one, I again consider my pivot in here. So the torque applied by the force of gravity is this way. The torque should be applied here by this purple base, and because the distance of this to the pivot is half of the distance of here, so therefore the force must be twice. It must be, if this is 5, this must be 10. So the F1 in this case is 10 newtons. And you can see in here, stop the video, go through this and you can see why mathematically. And now we forget about the torque. We forget about the torque and we focus on the forces now, the balancing forces. And of course the upward forces must cancel the downward force. Therefore this force must be make up for this, helping this one to make up for the upward force. So if this is 5, this seems to be also 5. So this force, I show it in here, the F2 equals 5 newtons downward, because these 2 5 must add together to cancel this 10. And you can see in here beautifully is explained, and the answer ended up negative, which means downward force.